Okay, hello whoever watching this video. I do hope that you enjoyed your paper 1, I suppose. So let's talk about how to prepare for your paper 2. So what we're going to do in this video, we're going to talk about the possible topics that could come up, as well as do some revision on those topics. And I will also provide some exam questions, which I will give some hints. And I would like you to pause and have a go at the questions by yourself. And the answer to those questions will be put on a separate video. So here are some possible topics that I think could come up in the exam. By no means this is an exhaustive list, so there might be more things that you might want to recap. But some topics I think would come up is binomial expansion, trigonometric equations, parametrics, differential equations, and so on and so forth. Out of those topics, I'm going to focus on the first 3 ones, which are binomial, trig, and parametric equations. If I have more time, I may make a separate video on the differential equations and proof by contradiction. So let's start with binomial expansion. Okay, so here are 2 equations that's really important for binomial expansion. The first one is what you learned in AS, and this is where this expansion is only valid for natural numbers. And that means n can take the value, let's say 1, 2, or 3, etc. Whereas what you learn in A2, you learn this expansion is valid for real numbers. So that means that it could be a negative number, like -1, or it could be a fraction, like a half. And the caveat to this second expansion is that firstly, it's an infinite series now, so we have infinite many terms. And also this is only valid, in other words, this expansion only converges when the modulus of x is less than 1. So usually students make mistakes with regards to the algebra, and in particular dealing with negative signs and manipulating the indices. So let's see an example where we want to find the first 3 terms of 2 plus x to the power of -1. Okay, the first thing we must spot is that this expansion is not in the valid form because we need 1 plus some amount of x. So the first thing we should do is we should factor out the 2. Now, we want to write that 2 as 2 to the power of -1 times this valid expansion. Often the students forget the -1 here because they forgot to put this number over here. Now, given that we have a valid expansion, we can now use binomial series. Note that it's very easy to make a mistake on the negative signs, so let's be careful on that. And then when we simplify that, we get what we have here. Again, we need to be careful that we have the correct sign here. With this now done, all we just need to do now is just expand out the bracket, and therefore we get a half minus x over 4 plus x squared over 8. Okay, so here's a question that you can have a go at. So for part A, we see that this seems like a partial fraction question. So hopefully you're comfortable doing that. Now part B is where we want to use the binomial series expansion to find up to the x squared term. So you could imagine, after we find the value of A, B, and C, we can take binomial expansion for each of them, and then go up to the x squared term. That is going to, of course, involve a lot of algebra, which is why it's going to be 6 mark. Part C is where things get very interesting, and they ask us to find the percentage error of this value f of 0.2. So what that probably means is we want to compare the actual value to the approximate value we get from the expansion. As mentioned at the start of the video, we're going to go through this question on a separate video. Good luck in the meantime. And here's another question. Part A looks fairly standard. And part B is where it's quite interesting. They ask us, giving a reason, if the expansion is valid. So think about what could that mean here. Okay, so the next topic is going to be on trigonometric equation. Now, it's quite difficult to go through everything we need to know for the exam, but I've summarized some of the important results we have to know. And those involve the Pythagorean identities, and we have the compound angle formulas. And in particular, let's note that there are 3 choices that you can make in the exam for cos 2x. And often it is the case that we want to choose the right version of the formula in order to solve or simplify a problem. And finally, but not least, we got the harmonic identity. Okay, so a few things to consider. The first thing, of course, is to make sure that we use the right angles, okay, whether we're measuring in radians or degrees. Similarly, we should also find all the solutions within the domain that's given in the question. This is quite easy to actually check in the exam by simply checking all the solutions you got and seeing if that actually works or not. The 2 things that's quite tricky is often finding the minimum maximum of a function, and this often requires some insight. And also, like everything in mathematics, having intuition is incredibly useful in predicting the next algebraic step. So let's see an example. The first example is to find the maximum minimum of this expression here. Now, as we notice, this expression seems quite similar to completing the square. And that's a key insight, because that means the maximum must occur when the bracket is plus or minus 5. The reason why it's plus or minus is because when we square it, we're going to have 25. And then when we add 3, we get 28. Similarly, the minimum occurs when the bracket is equal to 0. And so 0 plus 3 is 3. Okay, so let's do another problem. This problem is to prove that cos 4x is equal to 8 cos to the 4x minus 8 cos squared x plus 1. Now, the key insight again is to observe that the expression we got is in terms of cos. So at some point in the algebra, we want to make sure everything is in terms of cos. Okay, so the first thing we could do is to write this in terms of double angle formula. Cos 4x is equal to cos 2 times 2x. So we can use the double angle to write that as 2 cos squared 2x minus 1. And then we apply another double angle on this expression. Now the algebra is a bit annoying, but if you check the algebra on your end, you will see that you end up with what we wanted. And again, let's remind ourselves, the reason why we chose this version of cos is because cos 2x is because we wanted everything in terms of cos. So here's a question, and perhaps it looks a bit intimidating, partly because I don't really want to read and comprehend in the math exam. But nonetheless, part A looks fairly straightforward because it's simply about harmonic identity, and we're asked to find the value of alpha and possibly r as well. Part B is where we want to find the minimum value, and this here will require some insight in order to find the minimum value. Part C actually is surprisingly very simple if you look at the diagram which we're given. And part D is also fairly standard, where we want to solve for the value of theta and make sure we find all the solutions within that range. Good luck with that one. Okay, and here's the last topic, which is on parametric equations. And here are some key notes. Again, in mathematics, having intuition is incredibly vital, and this can often be complemented by the diagram that they give you in the exam. Now, the formula that you have to know, there are 2. One is about the derivative, and the other one is about the integral. The derivative, dy dx, is equal to dy d theta divided by dx d theta. Now, these equations are actually quite easy to remember, because actually differentials behave very similar to a fraction. And in particular, you could perhaps imagine the d thetas to cancel here to give us dy dx. Similarly, we see that the integral of y dx is equal to the integral of y dx over dt times dt. Again, by a similar, perhaps, argument that the dt seems to cancel and you end up with dx. So here are a few things to consider. Firstly, sometimes it's actually quite difficult to convert from parametric to Cartesian. In the simplest case, we just need to simply make t or theta the subject and then solve it. But whenever we're dealing with trigonometry, often it's the case that we need to use trigonometric identity in order to convert it to Cartesian. The next thing is to be careful with the limit on integration, because when we are integrating, let's say, we are sometimes integrating with respect to x or theta, and depending on that, the limit will change. And finally, but not least, we need to always use intuition and diagrams, okay, because that's going to help us with the question. Okay, so let's think of an example. Let's do an example where we want to find the Cartesian equation of this equation, x equals cos theta and y equals sine theta. And let's quickly show that making the theta the subject isn't as helpful as it might be. Well, we can write theta as cos to the minus 1 of x, okay, or the inverse cos. And that means that y must be sine of the inverse cos. Now, I think that's quite complicated, and so perhaps there's a more easy way to go about this. Well, we want to observe some trig identity that relates x and y. Well, here we know that we can relate cos and theta, cos and sine, by cos squared plus sine squared equals 1. And therefore, x squared plus y squared must be equal to 1. And that gives us an equation of a circle. Okay, so here's a question. And the first part, I think, looks fairly simple. We just simply want to work out a derivative. And then, based on that, part B asks us to find the equation of the tangent when t is at. So again, I think that's fairly simple. But the last problem, this is where things get a lot more interesting, perhaps, which is to work out a Cartesian equation. So the crucial insight is going to be, how am I going to relate x and y together? We have something that involves sine 2t, and we have something that involves cos squared t. So we want to find a way, a trigonometric identity, that will relate these two functions. Good luck with that part. Okay, and here's another question. Part A and B is fairly standard. A is about looking at the diagram and then checking that it crosses the x-axis at these 2 points. And part B is to use the integral formula to write the area as follows. Be very careful and make sure you understand why we have the following limits here. Now, part C is quite tricky, perhaps, and it requires some trick in order to solve it, to solve this integral. And the key idea is to realize that we're going to have some term that's going to involve the integral of cos squared. And perhaps you might want to remind yourself how you solve these type of integrals. Good luck with the last part again. Okay, so that's basically the end of the video. Good luck with all the questions. And as mentioned, okay, all the solutions of those exam questions will be provided on the next video. So I may or may not see you there, and good luck with the exam.